Welcome to a second example of converting a double integral in rectangular form to polar form. As we discussed in the previous video, to convert a double integral in rectangular form to polar form, we have to convert the function f of xy into a function in terms of r and theta, and then differential a is replaced with an extra factor of r dr d theta. So we can't forget about this extra factor of r when converting to polar form. Let's go and take a look at our second example. Let's see if we can determine the region of integration. We're integrating first with respect to y, which means y has to be greater than or equal to 0 and less than or equal to the square root of x minus x squared. So y has to be greater than or equal to 0 and less than or equal to the square root of x minus x squared. In the outer integral, we're integrating with respect to x, which means x has to be greater than or equal to 0 and less than or equal to 1. Let's see if we can determine the region of integration from this. Well, we know x is positive and y is positive, so we're dealing with the first quadrant. So let's focus on determining the graph of y is less than or equal to the square root of x minus x squared. One thing we could do is square both sides. That would give us y squared is less than or equal to x minus x squared. If we add x squared to both sides, we have x squared plus y squared is less than or equal to x. So we might want to type this into our graphing calculator, but we could also try to do this by hand by making a t-table. So we're going to go ahead and see if we can graph x squared plus y squared equals x by making a t-table. Well, if x is 0, of course we'd have 0 on both sides, y would have to be 0. And if x was 1, we'd have a 1 on both sides, y would have to be 0. Let's focus on what would happen if x was 1/2. Well, if x is 1/2, we'd have the equation 1/4 plus y squared must equal 1/2. So if we subtract 1/4 on both sides, we'd have y squared equals 1/4, and then y would have to be equal to 1/2. So from this, we might be able to determine that we'd have the graph that looks like this. Here's the point 0, 0. Here's the point 1/2, 1/2. Here's the point 1, 0. So because y has to be less than this semicircle, we would shade below, meaning this would be our region of integration. Let's see if we can start to set up our double integral from here. I'm going to go ahead and label this curve. It was the curve y equals the square root of x minus x squared. So now we have our function f of xy equals x times y. Let's see if we can determine f of r theta, meaning convert this function into polar form. Remember, x is equal to r cosine theta, and y is equal to r sine theta. So f of r theta would be r squared cosine theta sine theta. So when we go to our double integral in polar form, here's f of r theta, so we'd have r squared cosine theta sine theta. And don't forget we have an extra factor of r and then dr d theta. So now we need to determine the limits of integration, first with respect to r and then with respect to theta. And so this one's going to be a little bit tricky. There's a couple ways of going about doing it. If we don't recognize the polar equation that would create this semicircle here, we could go ahead and take this curve here and rewrite it as a polar equation. So let's go ahead and do that. We would have y equals the square root of x minus x squared, and y is equal to r sine theta. We'd have the square root, again, x is r cosine theta, and we'd have minus r squared cosine squared theta. Now if we square both sides of this equation, we're going to have r squared sine squared theta would equal r cosine theta minus r squared cosine squared theta. Let's go ahead and add r squared cosine squared to both sides. That would give us r squared sine squared theta plus r squared cosine squared theta equals r cosine theta. Now if we factor out r squared, we're going to have sine squared plus cosine squared, but that's equal to 1. Now we divide both sides by r. We have r equals cosine theta. So this tells us that the radius, this tells us we could use this polar equation to trace out the radius. So the limits of integration with respect to r would be from 0 to cosine theta. Now let's go ahead and verify this with our graphing calculator. So what I've done is I've put the calculator in degree mode because it's easier to read, and also polar form. And I've typed in r equals cosine theta. Let's take a look at the graph. Notice it does generate this half circle as well as the second half in the fourth quadrant. Let's see what theta would be. If we press trace, we can see that when theta is equal to 0, so we'd be at this point here. And then as we increase theta, you can see it does trace out the semicircle that we want. And when theta is equal to 90 degrees, or pi over 2, we're back at the origin. So that works perfectly. That verifies our limits of integration for r. It also tells us that theta would be from 0 to pi over 2. So notice for the limits of integration for r, if it was in terms of a function, it had to be in terms of theta. Let's go ahead and finish this on the next slide. Notice we are going to have r to the third power because of this extra factor of r. And now we're going to integrate with respect to r, treating theta as a constant. So if r to the fourth over 4, go ahead and pull out the 1/4. Now we're going to replace r with cosine theta. That's going to give us cosine to the fourth theta here, plus another factor of cosine theta. We'll have cosine to the fifth theta, sine theta. And then when r is 0, this would be 0. Now we're going to perform U substitution. If we let u equal cosine theta, then differential u is going to be equal to negative sine theta d theta. So we can replace sine theta d theta with negative du. So negative du takes the place of sine theta d theta. This would be u to the fifth. So we have negative 1/4 times u to the sixth over 6. Let's go ahead and rewrite this in terms of theta. We'd have negative 1/24. This would be cosine to the sixth theta. Well, cosine pi over 2 would be 0. So we'd have 0 to the sixth, is 0, minus cosine to the 0, which is 1. 1 to the sixth is 1. So we have negative 1/24 times a negative 1, or positive 1/24. That'll do it for this second example. I hope you found this helpful.